In part 1, we had gone over some of the very basic concepts when it comes to a chat system. What is a WebSocket? How do you scale? What are some of the challenges? And what does an overview of the system look like? In this particular video, we will be concentrating on the scalable aspect. How do you scale for millions of users? What does your message look like? How does the message flow ultimately to the receiving user? So all of that will give you a complete picture how a chat system actually works. Hello friends, welcome back to my channel. Now, before we go on to the specifics of how a message flows from user A to user B, we must first do a quick recap about what all do we already know. We went over this basic high-level design. I have my user over here. They make an HTTP request to a load balancer. You then authenticate if the client valid, what is the profile like, and then you will return a chat server. This user now makes a connection with using a WebSocket to the chat service and presence service. There can be other microservices as well. This connection stays open, and that is how the user will be able to send messages. And both of these microservices are connected to your databases or your key value stores. This is how you know, okay, these are all the messages that I have. This is the user information. These are all the images a user has uploaded. All of that data. The important point over here is that all of this happens as soon as you launch your app and probably your client loads up. All of this happens in the background. Now comes the interesting part, when you are actually sending a message. First of all, when you decide to send a message, you know that this message needs to be structured in some sort of a way, because this structure will ultimately help you to consume this message and distribute it to all the receivers, right? So we need to start somewhere. First of all, let us try to focus on a message structure. This is how I can make my message structure. Over here, I have a message ID, which will be my primary key. And I will go on to it in a little while. After that, you can have several fields: message from, message to, whatever is the content, and at what time the user created the message. This kind of sums everything you need in a message. You have the person sending the message, you have the receiver, and then you have the content. In this content, you can have anything. It could be text, it could be multimedia files, it could be locations to multimedia files, web links, anything. And this is the time. So what is the importance of a message ID? To be very honest, this is the most crucial part of a messaging system. This message ID is unique, and it will be unique for all of the messages that are present in the system. Now, how do you create something so unique that is different for all of the users, for millions and billions of users? What do you do about it? That is where the concept of a unique ID generator comes in very, very handy. I have an entire video on a unique ID generation, and if you're unaware about it, I would highly recommend you to go over that video. So why do we need that? A unique message ID will help you to categorize, and it will determine the order of all of the messages that are coming in. You need to understand that, okay, this message came in first, and now you are getting more and more new messages. There might be a question in your mind, why can't you just use the timestamp? If you think about a very small system, yes, timestamp could work. But if you try to think about it a little more deeply, the timestamp is not a reliable field. There are so many different time zones in the world, first of all. Next, every device is managing its own time. The user can personally also alter this time by tweaking their settings. So, this system becomes ambiguous. You can never be sure, okay, which time is accurate. This system will only work if time is consistent across all of the devices. And that is very, very unlikely to happen. Also, if you think about it, the granularity becomes very tough. Because with time, you could have hours, minutes, then seconds, and then maybe milliseconds. But all of that information is hard to capture. So the problem becomes even more complex. So how do you solve this problem? You use a message ID, which is a unique ID, and it is very much granular. Now, how do you generate these IDs? There can be three different methods. You can have an auto-incrementing sequence that is maintained by an SQL database. That will guarantee that, okay, this ID is unique and you will keep on generating. But again, the problem is for SQL databases, you have asset properties and it is guaranteed that these IDs will be unique. If you choose a no SQL based system, then you don't have any IDs. Then you will be solving the same problem again and again. Okay, how do you ensure its uniqueness? After that, you have something like a global sequence generator. This is similar to the Twitter Snowflake approach. So you will actually connect to a server which will give you a unique ID. And this server is responsible for generating it. The way this unique ID is generated, it also keeps into mind that what is the current time. And mostly it takes the UTC time zone that is constant across the entire world. So in a way, you will have a unique ID also, and you will also ensure that this is the ordering of messages. That way you can be confident, okay, this message came in first and then this message came in. Apart from this, you can also have a local sequence generator, but that would once again work for smaller systems. So in our current scenario, the approach that works for us is a global sequence generator. And the auto increment and the local sequence generator won't be good for us. Just pause for a moment and understand why this message ID is important, because this will help you to synchronize your messages across different devices. We'll come to it later. But you must also understand that there can be a fraction of milliseconds difference between two messages coming in. But certainly, you need to decide a priority, which one came first. And that is what should be displayed across everyone's devices as well. Think about a group chat. If you have 20 people typing in, then you need to make sure at a microsecond level that, okay, this message came in first and then this message came in. And this feature has to be consistent across all of the groups of friends you're talking to. So that's why I'm constantly reminding you, understand the Twitter Snowflake approach. That will tell you how it ensures uniqueness along with the timestamp. Let us continue ahead now and look at our user journey. What happens when you decide to open the app and then you start to send a message? So first of all, you will make an HTTP request to a load balancer. You connect to an API gateway where all of the authentication happens. Now, this API gateway also has a pool of chat servers available. They are scattered all throughout the world. Based upon your geographical location, it will find out that, okay, this server is probably closest to you. And this is now returned to the client. The client will then open a web socket to this chat server, and now you are ready to send messages. So what happened over here? The process we did, this is known as the service discovery cycle. Basically, the user logs in, you authenticate, the server selection starts, and then user is connected to a specific server. This is gonna be their server for this particular session. What happens next now? Let us continue with our journey. The user has now established a WebSocket to a chat server. This chat server will now connect to an ID generator. As soon as you compose your message and you hit send, it will hit this ID generator and it will grab an ID. Notice that this ID will be unique across your entire system. You can uniquely identify this message. You get this particular ID and you will put it in your message template. The chat server will now take this message and it will send it to two different places: a message sync queue and your key value store or the database that you're choosing. This database kind of helps you to store all the previous records. You might have noticed in your chat systems, right, that there is an option to retrieve older messages. This is where all of these databases come in handy. When you make that request, you will be looking in all of your databases and then you return it to the client. So how did they go over there in the first place? As soon as you sent a message, that is where you're storing all of this. I know that you might be thinking, okay, all the messages are encrypted. How do I get them back? Well, the messages are encrypted in the flow. That means the messages are encrypted even when they are stored. But your client can read it. That is because it has a private encryption key. But let us not focus on that part for now. I want you to bring your interest to this message sync queue. This message sync queue is responsible for pushing out all of the messages to the desired recipients. And since it is a queue, it will maintain the order in which the messages are coming. it is also not necessary that each user will have their dedicated message syncing queue. It could be possible that multiple users are sending message to the same queue. Or basically, any user that is connected to this chat server can send a message to their individual queues. There can be multiple approaches possible. Over here, let us discuss this. Now let us try to understand what happens to a user B. This user B could be the person who you wanted to send a message to. This user will also use the same protocol and obtain a chat server based upon their nearest geographical location. And this user is also open and ready to send and receive messages. What happens now? This message queue could be a Kafka message queue also, or rather some kind of a message queue that has a publisher and a subscriber model. If you do not know anything about Kafka or such kind of queues, I have a system design topic on that as well. So just refer those and all of these things will make sense. The basic idea is there will be a user B queue. So this particular queue can have a topic that this topic is for user B's incoming messages. And similarly, you can have multiple topics in this queue. User B's incoming messages, user C incoming messages, user D incoming messages. And this chat server sends all of these messages. What will this chat server do? Notice that both of these chat servers are different. So how do you know that a particular message was intended for user B? What this chat server will do is, it will connect to this message queue and it will subscribe to the topic. It will subscribe to the topic of user B's incoming messages. This message queue would have delivered all of the messages to this particular topic. So what is going to happen? If the user is online, this chat server will pull all the messages and start delivering it to user B. If in any case, this user B, let's say, was offline, so what will happen? This message queue will notify the push notification service that, okay, this particular user B has some incoming messages. This push notification service will now send a notification to user B. And based upon the operating system, you can decide, okay, this is how I want to send a notification. User B got a notification, and whenever they decide that, okay, they want to read the messages, they will start up their service. They are going to connect to a WebSocket, and this chat server will now pull all of the messages from the database. And once again, you will realize the importance of the message ID. Since you have all of these messages in your database now, you can just determine, okay, these are the message IDs and this is the order in which all of the messages came. I think you are getting a bit of an idea now. You might have seen sometimes in the notification, you see the message, but when you open up your client, you don't see the message. Why is that? Because your client hasn't yet pulled up all the messages. It was just a notification service telling you that, okay, you had a certain message coming in. So what have we done up till now? We have established a user journey for a one-to-one connection. This person is talking to user B, and this is how the flow would look like. If you try to think a little bit, we can kind of extend this flow to a group messaging service also. And how would that look? Let us say for now, we have a group of just 3 people. You can expand upon it later. So the first part will still remain the same. You have a user who establishes a WebSocket connection to the chat server. Once again, you will grab an ID. All of this process remains the same. And now you want to send the message. Before even sending the message to a message queue, what will happen is you will have some API gateways in between. And you know about all of the user profiles also. This is where you are going to validate that, hey, is this user present? And if I am sending the message to the correct set of users. For example, you send a message to 5 different people. And you can use your database to actually verify if all of these 5 profiles are legit. You may discover that, okay, only 4 of the persons are legit and the 5th person doesn't even exist on your chat system. This is where you can apply all of this filtering. And if you think about it, you can also have some security protocols in place. In your databases, you can actually store some of the group information as well. For example, this user shouldn't be able to send messages to a group to which he doesn't even belong. So all of these kind of validations, it will happen over here. As soon as you have determined that, okay, this person is sending messages to the correct set of recipients, what are you going to do? Instead of sending your message to just one queue, you can send messages to two different queues, or rather, two different topics. It is up to you how you make this implementation detail. Because what could happen is user B can have a different message queue that he's connected to, and user C can have a different message queue that he's connected to. I would say that you take this approach with a grain of salt, because depending upon the chat system and your design scope, this design may not be valid. Because over here, I'm suggesting that if you have 10 different users, you maintain 10 different message queues. It will work for smaller groups. But if you make a group of 5,000 people, then you are duplicating a message across 5,000 different message queues. And then it will not be a good design. In that case, you can go to a publisher and subscriber model. What you're going to do is you will just publish your message to a certain topic, and it will say that, okay, this message is intended for all of these subscribers. All your users can now subscribe to that topic and then start receiving those messages. That is why you might have seen that in different chat systems, there are different limitations around the number of people you can have in a group. Even if you think about it, even WhatsApp just increased their limit in the past years. So what does that mean? This design is constantly evolving. And that is why I keep saying that keep on discussing with your interviewer what do they want, what do they have in their mind, and rather what is their specific use case. Based upon that, you can keep on elaborating your design. I believe now you're getting a little bit of idea how these chat systems are working. We have established what happens as soon as you open your client. How does a one-to-one messaging look like? How can you upload images? How can you have group messages? But if you notice, we are missing out on one part. We also discussed in the initial phase that how do you synchronize against devices? You have seen it, right? You can open Telegram on your phone and you can open Telegram on your desktop as well. So what is happening over there? And once again, you can utilize the magic of unique message IDs. Because when you have unique message IDs and they are guaranteed to be in increasing order as well, you can take many more advantages. For example, I have user's mobile. So the user is primarily using their mobile phone, and the maximum message ID that is on their phone, let us say, is 765. It is a random number. This user has established a web socket to the chat server and they are communicating with any of their friends, correct? Also notice that all of your messages are encrypted and stored in your databases. The chat server is constantly communicating with it. Now, what happens as soon as you open up your laptop? Let us say you opened up your laptop, and how do you authenticate? You have some kind of a QR code on your mobile. You scan it and now you are connecting. So there can be one idea that using that QR code, you connect to the same chat server. So now you have established the same kind of a web socket with your chat server. And now you can understand. Let us say on your laptop, the maximum message ID that you have was just 690. So what does that mean? It means there is a certain gap of messages. This chat server knows about both of these. So now you know, okay, I was at 765 on my mobile. So now you will start fetching all of the remaining messages one by one, and they will reach to your second device. And this counter will keep on updating until it reaches 765. When your client is open, it will say that, okay, both of the devices are now up to date. And you might have seen this also. You will be on your web client and it will say, keep the client open while we fetch all of the latest messages. So this is what is happening in the background. I believe now you understand why I emphasized so much on the message ID and how you should use it as your primary key and how you should use a unique ID generator to get that primary key. What else can you think about in a chat system? You might have seen the presence indicator also. Is a person online or not? And once again, that is achieved via a WebSocket. If your interviewer asks, okay, what about a scenario when the user is in a flaky internet kind of a place where they have a connection sometimes and they lose it? Do you keep seeing offline, online, offline, online? No. What usually happens is you can have some kind of a heartbeat service. Every 30 seconds, you look in your WebSocket and try to determine, hey, is the person online? In that 30 second, if there is on off of internet, then you don't have to worry about it. But if at the end of 30 seconds, or if after two consecutive checks, you still find that the user is offline, then you report it back. So these are all some kind of tiny things that you can improve upon. And as I said, just keep on communicating. Because if you understand the use case of the interviewer, you will design a better system. And I hope this kind of clarifies things. If you still have any more doubts about the chat system or any of the design choices that we used, just tell me everything in the comment section below and I would be happy to discuss all of it. This is really interesting when you have a lot of questions coming up. And as a reminder, if you found this video helpful, please do consider subscribing to my channel and share this video with your friends. This really keeps me motivated and I can make more such informational videos. Also, a huge shout out to all of the members who support my channel. You guys really keep me going. And as a member, you do get priority reply to your comments and early access to new videos as well. Stay tuned for my upcoming video. Until then, see ya.